All
Hello?
right.
Yeah, you hear me too.
It's good to see you,
Good.
Flavio. Yeah.
Same here. Yeah, good to see you. Great. I was just trying to keep up with everything that you posted recently. It's difficult, but
Sorry about
um,
that.
nah, never mind. It's great. I was just finishing your last conversation um, with
Roman.
Roman. Yep, exactly. I'm bad with names, sorry.
Yeah, no, that was a wide-ranging one. Um,
Yeah, that was great. Really going from like fundamental ideas to political implications. Very
mhm,
interesting. Yeah,
mhm. Yeah, well, I'm excited to see you start your YouTube channel and share some of
we'll
your
see
own
how that
ideas and
goes.
approaches to these questions. It's really encouraging for me to have to see more scientists and people with a background in physics getting interested in Whitehead's interpretations and sort of finally taking a look at some of the philosophical puzzles and implications sort of behind the scenes that physicists have ignored for most physicists for a century or so.
Yeah,
So I hope this is a new trend that you're a part of here.
fingers crossed.
Yeah, yeah. So yeah, I hope you plan to continue uh, that series.
I do.
It's an engaging format, and you've got a good way of gently easing people into what could very easily be confusing and difficult ideas. So yeah.
We'll see how that goes. Um I always have like too many um projects going on. Having a family and I'm like working as a teacher, but still also having to like finish my sort of diploma to be allowed to be a teacher. And yeah, I would also like to like find more time again to for training and meditation
Yeah.
and everything. Yeah, but I think actually, if you don't mind, the in terms of Whitehead and his ideas and physicists being like interested in those ideas, I think for me at least, it's felt like so um, obvious or like necessary, necessary, necessary. Sorry, my English. Um, because because we physicists, I think we should at least know that we have a problem in quantum mechanics. That quantum mechanics fundamentally sort of needs this additional sort of satisfactory moment that in physics we just call the collapse of the wave function, but something that like changes quantum mechanics into reality. I think that should be so obvious that this is not part of physics at the moment. But and I never understood while studying physics. I never understood why this was not a problem for more people. But so this is where I really sort of caught on when I heard about Whitehead's ideas, because to me at least it was like so the process of concrescence felt like such a natural way of describing what we describe in physics in quantum mechanics. It's so similar, even sort of in wording sometimes, to me. But it offers the solution, which physics did not. So I was just so thrilled. Um,
Yeah. And it's no coincidence, right? Because Whitehead was writing and developing this metaphysical scheme in the 1920s. and trying to really respond to the beginnings of quantum theory and also relativity theory. And so
Mm-hmm.
that was his goal, was
Mm-hmm.
to um, speak the language of the latest physics and recognize the ways in which, yeah, that old understanding uh, in classical physics of a universe that exists independently of our observation and our measurement turned out not to be uh, an adequate way of framing the situation. Um, but I mean, what, in your opinion, what's the reason that 100 years ago, as these ideas are formulated, that physics decided not to go any further with trying to explain the results that they're getting?
Yeah.
Um, I mean, on some level, there's dozens of interpretations, right? Um,
Yes.
but no consensus.
So I think there's, in my mind, there are two main reasons. One of which is that the transition actually sort of went step by step. So even though it looks like just this one momentarily big shift in like from classical physics to quantum mechanics, like everything changes, but actually quantum mechanics was developed gradually. And in the beginning, it was absolutely clear that this was just meant to be a sort of mathematical trick that we needed to use for a preliminary time until we understand things better, and then this math will go away again, right? So the Planck's constant, this h, for example, was introduced similar in a similar fashion as when you do calculus, you introduce a finite length that then you take the limit of infinitesimal smallness and then it vanishes again. So then you don't need this h anymore because in the limit you get continuous functions. And so the hope was that at some point we would be able to take a limit function and then everything would be smooth again and without these weird quantization jumps that we needed to explain things. So that was on a mathematical level, the hope that this would just go away again. But then also, um, um, quantum mechanics was never meant to be a theory about the world as a whole. It was strictly meant to describe just these isolated systems that still interact with a normal, reasonable, classical world. But just when you isolate small parts like atoms or something, then they start to behave in weird ways that we need some quantum mechanical weirdness to describe until it interacts with the real world again, at which point we call that the collapse of the wave function, because the collapse was meant to be the interaction of the quantum mechanical system with the reality of the classical world. So you have like a real apparatus sort of shielding the quantum mechanical system, where thereby sort of invoking quantum weirdness inside. But then when this interacts with the apparatus, giving a measurement, that again is like the interaction with classical world, and everything's fine again from there on, right? And so this was, I remember very clearly when I had to like look this up in one of the Russian textbooks, because I was told that if you really want to understand a theory, you have to go to the Russians because they always sort of nailed it in a deeper to a deeper understanding. And there's this big volumes of Landau and Lifshitz describing all of theoretical physics, like if you really want to have the math right, you go there. And I very clearly remember reading that part of Introduction to Quantum Mechanics where he says like quantum mechanics describes a system apart from classical physics, and for ease of use, we will call a quantum mechanical system a electron from here on out. And then he only talks about electrons as quantum mechanical. And so this is, I think, one important reason. It was thought that it would just describe sort of temporarily in space and time, sort of a small part. So we need this description for now to describe a small part of the world, but the rest is fine. And only gradually it became clear that, well, but if we describe atoms that way, and if we think that all of matter is composed of atoms, then actually everything is quantum mechanical. But then we have like entanglement that goes on and on and on forever, and there's interaction from the Big Bang to now, and nothing is like Schrödinger's cat never decides whether she's alive or dead. This can't be true. And then these interpretations started to sort of pop up. Um, and as you said, there are many of them. But then, so that's one reason number one. And reason number two, I think, is a cultural one, that during that time, physics shifted sort of also while sort of moving from being very much Europe centered to being more and more America centered. Also moving from being really about understanding the world more and more to be almost engineering, sort of needing to yield results, right? In that time when the atomic bomb was developed as sort of the biggest project in physics, right? It was sort of, but actually that's an engineering problem. But physicists were sort of, um, sort of, yeah, almost like they needed to develop a theory to be able to build this thing or to decide whether it's possible or not, because the Americans were afraid that the Germans had it, even though they didn't. But so there was this race, right? And so this that's right. That's where when Feynman's quote "shut up and calculate" sort of comes in very strongly, that physics shifted from having this responsibility to explain itself to just yielding results. And I think that's the second important reason.
Hmm.
That was a
Very
longer
interesting.
answer.
No, I love it. I love it. So there's the more theoretical issues of the founders, many of the founders of quantum theory thinking that this was a stopgap sort of mathematical way of dealing with confounding experimental results that eventually we would be able to explain in a traditional kind of deterministic way. And this was
Exactly. Once we understand things better, this weirdness will go away. Yeah.
right. Uh, Einstein and I mean Bohr didn't agree with that at least, but Einstein did and others, and they kind of had quite a battle with each other over this question: is quantum mechanics complete or
Yep.
not?
Yep.
Um, it seems like, given experiments on entanglement and non-locality and whatnot in the interim decades, it's pretty clear that it's not incomplete. It's describing something as well as it can be described, though there's still the issue of unifying it with relativity and gravity and everything.
Yeah.
Maybe
Exactly.
we can get into that. I have all sorts of questions about that, but um,
I'm not sure I have any answers.
well, you might help me at least. But maybe we'll get there. But then the other question is the difference, if there is one, between the quantum and the classical realms, and whether or not, yeah, is the whole universe a quantum system? What do we mean if we when we talk about the collapse of the wave function? Um, are the quantum effects only a result of a very isolated, abstracted uh, system that is averaged out when you talk about, larger systems? And with cosmology nowadays, as a result of, the Big Bang model, the idea is that the whole universe has expanded from a singularity, and so these quantum effects all of a sudden become relevant everywhere. Um, so that's on the theoretical side. And then I like what you say about what happened when quantum theory shifted from this European context, where there was more interest in the theoretical interpretation, to this more pragmatic American cultural context, where obviously in the middle of the war we want to get the bomb built, and so it's more of this engineering mentality, um, where it's just, let's figure out how to do the calculations right to build this, um, leaving the theoretical interpretation to the side. Uh,
Yeah, and I think this has continued into sort of our modern time, right? The sort of usefulness of science is often very strongly, um, linked to its technological results, right? So why do we need science? Because it gave us digital cameras and smartphones. And so obviously those are good. So that's why science is good. And I think yeah, we as our sort of our guild, we as scientists and physicists in particular, we are not held to the standard of yeah, like needing to be able to explain ourselves that well from society anymore, um, which I think we absolutely should. It would sort of um, also a little bit like show us our place, I think, in society. I think science and physics is a bit overrated in our world view of things, because like a lot of people, I think, um, don't really bother to try and understand physics, but then also are very physicalist in their worldview. So they think physics has all the answers, even though they don't really bother checking them.
so, I mean, it seems questionable today whether or not the best models in fundamental physics are even adequately described as a materialist ontology. I mean, because
Yeah, true. There's no
certain,
real material there.
yeah, I mean, the idea of locality is out the window. The idea of nature at an instant is out the window, even though point instants are an important sort of aspect of many models
Hmm.
in physics. It's clear that if you're talking about actual events in nature, the attempt to model them based on point instants is always going to be an approximation. Um, and so, is physics even materialist anymore? I don't think so. We're talking about pervasive fields, and something like an electron is a very useful. Uh, I mean, this is a question, not a statement.
Okay.
Is When you talk about an electron, is this a useful theoretical um, abstraction that allows us to make sense of uh, measurements and predictions that are technologically useful? Or would you say that no, there is such a thing as an electron, it exists in nature, and we have discovered
Huh.
it?
Okay. So ontological question. um, and I have to specify, you are asking me as an individual or me as a physicist representing
Well, if
physicists?
there's different answers, I would be curious how
Okay.
you answer it with wearing your different hats. But just to
Yep.
express it a little bit more clearly,
Hmm.
electrons are said to have, they don't take up any volume. They're just
Yeah.
points, right? And so when we think of what nature is, we a point is a kind of Platonic idea. Like we can imagine it,
Yeah.
but you can't really locate one in the real world, right? And so when I ask, is an electron a theoretical entity that's very useful for making predictions, or is it a thing that we have discovered in the world? That's kind of
Okay.
the context, yeah. But whatever, wherever you want to
So
go with that.
thank you. Cool. So because I was asking because me as a person, I'm very much inclined to interpret an electron as an event that is probably actually really happening, and in a Whiteheadian way, I think. Um, so I would think that it's it means something to be an electron, and in that sense, it will be real, as so far as it has. I think. Let me try. So I would say reality can be ascribed to a moment or occasion in exactly as far as it has consequences either for its own reappearance in like a later time, so sort of as a repetition of itself, and or consequences upon other events, so strictly relational. So reality is whenever there's shared interaction and consequence of that interaction. So I think, yeah, reality is consequence of interaction. So an electron can be something absolutely real if it has any consequences for either itself or anything else. That would be my personal personal answer. And then more precisely what I think it is in terms of how we as human beings can talk about it and make sense of it. So yeah, as far as I understand the current, or not current, but the theory that was taught to me, um, the idea is that there's one singular electron field permeating all of reality, all of the whole universe. And this electron field can have excitations in it. And these excitations have they come in quantized lumps. And these lumps we call electrons. And they are sort of fluctuations in that field. And they, again, show themselves in terms of like being able to influence other things as non-local points that have specific attributes. So there's a non-local smeared out point like wave like excitation in a global field that has specific attributes. There's a specific mass attributed to this point and a specific charge and a specific spin. And these things again show themselves to be present in this smeared out point. Or yeah, in by virtue of being of interacting with other things. Who so and maybe to make more precise this idea of a point but also like smeared out thing, there again is this idea, right, of the smeared out thing and the wave excitation of the field, that's the quantum mechanical description of it. But then you need a collapse of this wave function into a actual point in space from where this interaction can propagate outwards. And after this momentarily collapse, again the wave function will smear out and the thing will be non-local until it is localized again. And again, the most useful interpretation, I think, from quantum mechanics, when or why this collapse happens, needs, I think, to be based on some kind of interaction with something else. And there's the idea that if there's just enough interactions, there's sort of a critical mass, at which point really there is a noticeable sort of threshold that makes it collapse. That's sort of Penrose's idea of objective reduction, that you have this objective threshold that you could figure out, and then you would know at which mass of a quantum mechanical system there's a collapse. And I think that to me is the closest to a reasonable interpretation of quantum mechanics. Yeah.
Interesting. So I have a few more questions about this. I think you did a great job trying to describe the something tangible yet mysterious. So every electron has an identical mass.
Mm-hmm.
Is that true? And then some of
Yes.
these other attributes like spin, right, would be there's several different kinds of spin an electron can have, right?
E no, no, an electron always has spin one half,
Oh,
right?
ah,
Or
okay.
and
So
you
maybe
have
Dave.
excitations in that.
So is every
No, yeah.
electron identical?
Yes, yes, and actually there's a interpretation that I heard of like quantum field theory, because in quantum field theory you also have the opposite of the electron, right? The antimatter particle, the positron, which in quantum field theory is described as an electron moving backwards through time, or can be described that way, and which I also never fully understand. But so there's one interpretation, which I heard, is that actually there's only one electron that's just traveling back and forth through the history of time of the universe. And so there's multiple sort of iterations of that electron present at any given time, because it's moving back and forth through time and sort of making copies of itself each time it passes back and forth, right? So in that interpretation, there only exists one electron, and they are all the same one. But yes, so with other words, yes, every electron is an exact copy of itself, basically, or of other electrons.
So, I mean, this might be too vast of a question, but when I, study the history of physics, it's often said that, I mean, for most of the 19th century, the luminiferous ether was sort of taken for granted. Like, if electromagnetic
Mm-hmm.
waves are a thing, they must be propagating through some kind of a medium.
Yep.
Michelson and Morley's experiment didn't seem to show evidence of this. Einstein introduces his gravitational field, and it's often said that we don't need the ether anymore, even though Einstein says, I think in the 20s, this is my gravitational field is a new ether, basically. And so I wonder, in the context of the fields that quantum physics is introducing, the electron field,
Yeah.
let's say, to what extent is this a new kind of ether? And to what extent do we need to not imagine uh, that electrons are vibrating in a medium, even though you said they're an excitation in a field? Is it a different concept, or can we draw some parallels here?
It's a very good question, but I think I'm not qualified to give an exact answer because I never really went that deep into quantum field theory.
Hmm.
But as far as I understood, the idea is very reminiscent of an ether, just with the very clear difference that it's always strictly relativistic, mean in the sense of like not being thought of as sort of a static background in a Cartesian sense of like a XYZ coordinate system that within things, sort of the stage within things play out,
Mhm.
but always as a yeah, as just
It-
in, again, in relation to other things, right? So we
mhm.
don't, there's no movement through the field other than the excitations move through that field, and there's a interaction with other things in this field. But but sort of it's not it's even more etheric, even more
Yeah,
ghost-like than the original ether already
right,
was. I think.
right.
I think.
So the original ether was conceived of as a very fine, subtle material substance of some
Yeah,
kind, and this
subtle but
new,
still there, right?
mhm. And this new
Mm.
ether is, in some sense, more abstract, and yeah, relativistic. It's not a container and through which things move. Um, Whitehead developed this idea of what he called the ether of events, uh, which is his way of, describing, uh, as you were, electrons are real in the sense that they are conveying, that interactions are being conveyed, and there's a propagation of influence. And
Hmm.
so, an electron, if we were to try to describe it in Whitehead's sense, it would be an occurrence. He would talk about electronic occasions.
Yeah.
Um,
Yep.
and we're talking about a rhythmic pattern that follows certain very precise mathematical rules.
Hmm.
Um, and that what's finally real from a Whiteheadian point of view is a certain uh, emotional valence, or a feeling of some kind. So the electron is a very simple type of feeling
Yep.
that's highly, highly repetitive. It's a vibratory feeling, um, and that gives us some content, but that by which we can connect to the meaning of what is otherwise a very abstract idea. I mean, when you talk about the spin of an electron or the spin of a particle, it's a spin in a higher dimensional space. It's not even a spin in
Yeah.
three-dimensional space, right? And so,
Yeah. It's not an actual. It's not an actual spinning spin. It's just a name that we need because there's two different kinds of things, and we call them spin one half and integer spin things. So yeah. Um, and one of the spin one half things, they actually can sort of bump into each other and repel each other by virtue of not being able to be in the same state at the same place. And the spin one things, these are like photons and so in bosons, they don't have that property, so they can be at the same place in the same state, and they can aggregate and form condensates. For example, if you concentrate light enough, you get this Bose-Einstein condensates of lots and lots of photons in the same place. And you cannot do that with electrons. You have this this rule that says they cannot be at the same place, so they have to occupy a different energy level.
And that's because of their charge, and photons have no charge or
No, of their spin.
their spin. Oh, okay.
Yeah, so there's these two kinds of things in the standard model, right? There's bosons and fermions. Fermions are spin 1/2 things, particles, and bosons are spin 1 or integer spin things. And the bosons, like photons and W bosons and stuff, they they are sort of the interaction particles, is the idea. And then fermions are sort of the matter stuff. So electrons and quarks are fermions, but then so the bosons are the things that mediate the forces, right? So the idea is that photons are also what sort of mediates the electrostatic interaction.
So, when you learned about Whitehead's metaphysics and his process of concrescence, what was the first sort of indication that you had that this might help you make more sense of what's going on at the quantum level?
Well, it solved two riddles at once, right? Because I was also already very interested in the science of consciousness and a little bit in the philosophy of mind, but more really like sort of the hard problem of consciousness of like why would matter make mind and how. And so the idea of being able to have a framework that naturally encompasses both aspects of like physical and mental as poles in this picture, and at the same time solving this fundamental unresting problem of like having no no story behind what a collapse of the wave function is, why it occurs, what's the and this sort of, and what quantum mechanics as a whole sort of says about the world. All of this, I think, was just sort of solved in an instant when I heard the description of you, when I heard you describing concrescence, this process of at the same time having this very deterministic influencing the prehension part of real, exactly sort of this, as a physicist, right, I was thinking exactly as like sort of forces acting on something, but that's actually not yet really formed. And then this something sort of coming together and gathering itself sort of and solidifying into existence, because you have this one additional ingredient, right? Ingredients that physics does not have, which is creativity. This one thing that actually drives the universe onward and forward, and because physics doesn't have that, right? There's nothing that really needs to go on in physics, right? There's often the question of like, why is there anything rather than nothing? Which I think creativity that answers the questions. If there is creativity involved, then obviously you get like excitement and interest in new things and excitement of new things like that, and so you naturally build things. You make a universe if you're creative, obviously, and it obviously wants to go on and wants to explore creatively more novelty and more things. And so it to me, it just solved so many problems in such a beautiful and simple way, because I'm still very much in love with the idea of like Occam's razor, of finding the simplest model or theory or yeah story to describe something. But I think this story just makes so much more sense than a story that does not have anything like creativity in it.
Yeah. Whitehead calls it sometimes the principle of unrest,
Yeah.
that there is this ongoingness and nothing in the universe ever happens twice. Um, and so, yeah, concrescence is meant to apply at the level of fundamental particles on up to our own conscious human experience. One category to rule them all, as it were, all of these scales. But the key is, and let me know if this matches your understanding, is that Whitehead is saying it's the wrong problem to ask. How does a lot of times the way this gets framed is the observer, the conscious observer, collapses the wave function, and the implication being the human conscious observer. And Whitehead says no, no, all of these uh, forms of self-organization in nature, whether we're talking about atoms or uh, cells or human persons, are capable of making decisions. And a decision isn't necessarily conscious. It's a process of self-actualization, which is just another way of talking about concrescence. And so there's a bit of mentality or a mental pull, even in an electron, which is part of what allows an electron to make a decision as it relates to an environment about which potentialities it's going to actualize. Um,
Mhm.
and that doesn't depend on a human being coming in and looking. Um, nature, in a Whitehead's pan-experientialist understanding of the natural world, nature observes itself all the time.
Yeah.
Um, and so, in other words, nature's measuring itself all the time. And this seems to me to be the far more. So it's interesting you bring up Occam and like parsimony and the simplest explanation, because on the one hand, you and I might find that Whitehead's account of this is far more parsimonious, but then there are other people like Hugh Everett and Sean Carroll nowadays who defend this many worlds interpretation, where they think the simplest explanation is to take the wave function and say that is the whole of reality. You don't need to do any more interpreting. It's just every possibility is actualized in some parallel universe. Now, yeah, I think for us, that's like the opposite of parsimony. You're literally uh, imagining infinitely many other universes, uh, branching out moment by moment by moment. Um,
Not even like moment by moment, but also like in time, continuously,
continuously, yeah.
continuously many moments in time. You branch out continuously many universes at continuously every space in space.
So from Carroll's
This,
point of view, that's
yeah,
parsimonious because you don't need anything more than the wave function. But from our point of view,
but you
you're
still do. I
mm,
think you still do, because we do not experience all of them.
right. So how do you
So
explain
you
that?
just push the problem from physics to mental, and you ignore that. the why does our consciousness choose one and not the other, then you just have the exactly same problem. You made the other part way more complicated just to be able to like take this one problem out, but you still have the problem in you just it's just a magic trick. You just put it in your pocket, but it's still there. The problem is still there. You still need to explain why our consciousness chooses one particular reality all the time. Then, to I think I don't
Hmm.
know if there's an answer to this question.
That's no, that's very insightful. I hadn't considered the way that many worlds interpretation is sort of it's presupposing what Whitehead called the bifurcation of nature. And
Yep,
so our subjective experience and our inability to understand how it is that we only perceive one timeline is a function of our own perceptual limitation, some kind of illusion that a spell that we're
exactly.
under. And
Let's
so,
not talk about that
yeah,
because consciousness doesn't exist. And then, yeah, then it's simpler. Of course, a universe without any observer and without any consciousness in it would probably be like an universe that's more easily describable mathematically than one with it. But that's not
there'd
that
be
was
no one there
not
to do the mathematics, unfortunately,
yeah,
but
that was not the homework that you were assigned to, you know. you
mhm.
had you had your job is to explain reality, and reality includes knowing that it's real because I see it. I know. It's so I don't yeah, I don't understand this idea of epiphenomenalists like having consciousness as something that we don't need to explain because it just is this whistling on the whistle of the train. But you know, on a train, I can still explain how the noise of the whistle comes about when the steam blows out through this whistle. And epiphenomenalists cannot explain how consciousness comes about. So this is a difference. And in the very many worlds interpretation, I don't see that solved at all. And I think it's just giving up on the problem, sort of, or yeah, giving up on the complications, and just saying it doesn't exist. But yeah, I don't think that makes it go away if you just ignore it. And
Right.
you were talking about this other famous interpretation, right, of the Copenhagen interpretation, where the collapse happens via interaction with consciousness again, right? So consciousness was in this picture from the get-go, right? So somehow it was obvious that those two things are linked, and I think it's very unfair to, for example, to Penrose, that he's often quoted as saying quantum mechanics and consciousness must have something in common because they are both weird and we don't understand them. That's not what he says, and also I think it's obvious that this problem of consciousness was very obviously linked to the problems of quantum mechanics from the beginning on. And yeah, so there first was the idea that the collapse happens by the interaction with the classical world, and then this was pushed to the interaction of like the measurement moment was pushed from the apparatus back to an conscious observation of the measurement apparatus. And so it was pushed into consciousness. But then you all have a very extreme dualistic situation, right? Because you forbid the possibility of consciousness being part of the physical world because you need the external interaction of the physical world with an external consciousness to make physics work And so you forbid any kind of bridge between those worlds. And so I think the you need some kind of mentality interwoven in all of reality. Otherwise, I don't see any solution to this problem. I think that's the only solution forward is if we admit that this is only a problem in our worldview, because obviously then that means we have the wrong worldview, right? We that I think that sentence didn't make any sense.
No, I follow you.
Okay.
I mean, so the challenge is how do we arrive at, I mean, for Whitehead, metaphysics is about finding generalizations which apply across as many different disciplines as possible. And
Hmm.
so, is there a way that we can develop concepts that apply as much to our experience as conscious agents, making the decisions that we make, exploring possibilities before deciding on which possibility we want to actualize? Is there a way that our experience of that can be generalized to what's going on in a quantum event and a field of probabilities that gets actualized? And so Whitehead develops this idea of prehension, and there are physical prehensions and conceptual prehensions, and every actual occasion, whether it's an electronic occasion or an animal occasion,
Hmm.
includes both of these poles, the physical and the conceptual. And the physical is just feeling what's already happened, conforming to its causality, basically conforming to the past, its efficient causation. Whereas the mental pole or conceptual prehension is what he would call the ingression of possibilities,
Yeah. Okay. Hmm.
right? It's the feeling of alternatives. Um, and in our human conscious experience, we can we can explore possibilities and select one in a simple you know particle or electron. There's not as much imaginative freedom, but nonetheless there's a decision which occurs to actualize. There's not a determinism there. We know that.
We
There's
know exactly. We know we have. I've made the experiments, um,
and so
and yep.
Whitehead's wager, his speculative wager, is that we can make an analogy here that there's some degree of freedom to decide even in an electron. It's not conscious, it's not considering the options, um, but it's having to choose.
Yeah.
And there must be some degree of mentality even at that scale. And it's like a fundamental attitude in response to the existence of consciousness. And when we do science, so often um, the the attitude is, I, first of all, I need to simplify the situation. If I include my own mind in nature, it's going to be much more difficult to offer a simple mathematical deterministic equation that will describe what's happening. So can I just focus on the behavior of measurable forces and leave myself out of the equation? And that did physics really advance quite well with that assumption for a few
Yeah.
hundred years, but eventually got to this point applying the most reductionistic methods where that didn't work anymore. Um, your choice of what to measure, you want to know the position or the momentum, because you can't know both, right? All
Yeah.
of a sudden, our decisions are seemingly affecting the measurements, the systems at least that we're trying to measure. And so Whitehead's suggestion here is that we really need to bring the mind back into nature and understand ourselves as a very intense, um, amplified form of experience or prehension that's actually pervasive in nature. And so then we have one set of categories through which we can understand everything, instead
Hmm.
of having to think that consciousness is some weird epiphenomenal anomaly that has no place in an otherwise well-behaving natural world, except that it doesn't behave as we expect because of quantum theory. So that's the challenge. that Whitehead's
Hmm.
trying to address, right? And it seems like yeah, it's a hard pill to swallow, I guess, from the perspective of classical physics, but it seems way easier to swallow than many worlds interpretation.
Absolutely. And I mean, quantum mechanics still gives us additional information in all of this, right? Because it gives us the exact description of the spectrum of possibilities that the electron can choose from. We have the exact probability distribution that we know most likely it will just, follow the pack and do exactly the same thing as it did before, but it has a smaller degree of possibility to choose differently this time, and it can be sort of rebel and be at the outskirt of the probability function. But it's almost definite that it doesn't turn into a bird and fly away at the next instance. it's it's possible that it can like do something weird, but we can describe its range of possibilities, and I think that is again much easier understood in this framework than in the just framework without where we cannot say the word choice
The
because it's forbidden.
the constraints for what an electron can do are increasingly limited when it's part of a larger system, right? Like if it's
Yep.
part of a carbon atom or something, we know with even more precision how the electrons will behave versus if it's in an isolated situation somehow, then it's more unpredictable. Is that right?
Yeah, yeah, exactly, exactly. It's I would say again, the more interaction it has with other things, the more closely defined its reality and its existence sort of becomes, because it has these constant this constant feedback sort of from its environment of who it is and where it is, and so that makes it behave much more reliably and yeah, more easily describable. I'm looking at the clock. I think you have to run soon already. Is that true?
Yeah, got a few more
Yeah.
minutes here.
Okay.
We're gonna have to do another round because I have.
I would love to because I was doing much of the talking now, but actually I wanted to ask you questions
Oh,
and
I'm sorry.
because I find when I watch these videos, I always find the parts where you speak much more insightful. And so I didn't want to speak that much, but nevertheless, thank you for giving me that opportunities.
Oh no, I'm trying to learn here from you as well. And just on this last issue, Whitehead has his category of societies, which has to do with the relationships among actual occasions. And there's a way in which, he wants to describe as nature becomes more complex and you get these enduring patterns that we could call atoms, stars, galaxies, planets, cells, plants, animals. These are societies of occasions of experience that have an enduring pattern that they're reliably repeating. And so it's a matter of uh, when quantum phenomena become increasingly entangled in these uh, relationships, they're more predictable. But what Whitehead is trying to say is as these as this social order and the habits of these social relationships build up in the course of evolution, there's also uh, something occurs where a space is created within that social order for more novelty and freedom to be sheltered, as it were. He uses that word, sheltering. And so, like in the case of the brain of an organism with a nervous system, um,
Hmm.
he wants to he wants there to be a great degree of freedom, sort of protected and sheltered within the organism for more probabilities to be explored. But that presupposes and depends upon the constraints provided by the rest of that system, which is very highly ordered. And so it's this interplay between habit and novelty that
Hmm.
allows for consciousness as we know and love it to emerge
Hmm.
um, out of this more primordial form of experience. But something has clicked for you. What are you thinking?
Yeah, yeah. Sorry, I was trying to look up something that I heard you say in another talk when describing these hierarchies of systems. I think you said something of like an amplifier of something.
Yeah,
I'm not sure.
he says the human body functions as a complex amplifier. It's an analogy that
Complex
he uses.
amplifier. Yes, exactly, exactly. Um, and because this ties into something that I really wanted to talk with you about as well. And this is this idea of the scale-free nature of his picture, and this idea from solid-state physics that, for example, in the so-called Ising model, that was developed to describe magnetism in solid magnets like iron, where you have these little spins again pointing one way or the other, and if they're all aligned, then the thing is magnetic. But in a at first they are sort of randomly oriented, but they all influence each other, and so you have these pockets that are already aligned, but then you have another pocket that's aligned in a different direction next to it, and you have this, and the size of the pockets are at all scales. So you have pockets from like just one thing being that way and then the other, to like really big parts that are already ordered, and you have sort of, yeah, pockets at every scale. Um, and this is very important that because then you can describe the system just through one simple parameter, the so-called order parameter, and this has a critical value at which then the whole thing flips into one or the other orientation and becomes magnetic. And the interesting thing is that at that moment, when it flips, it the whole system becomes susceptible to all parts. So it really matters what every single spin in this system is at that very moment, whether it will flip up or flip down as a whole. So and only at that moment actually it can be described truly scale free. And there's a mathematical proof that you can show that those things are sort of identical. So if you have a scale free description of a system, that automatically means it's susceptible to all the parts. So for me, that means if the universe can be described in a scale-free manner, so you have actual occasions and they can be at any scale, and it works, that automatically means that every single occasion in the universe has the capability of influencing the whole universe, which I think makes the question of our human interaction with the world so much more exciting. because because then if every decision that you make and every decision that every electron makes can in principle at least have a profound impact on the universe as a whole and its whole history, that's I think that's quite exciting.
A lot of
Sorry,
responsibility
that
as
was a lot.
well.
Yeah,
I think,
yeah, yeah.
this is where Whitehead would, and we can question his choice of language here, but this is where he would talk about the consequent nature of God, which is this sort
Right.
of where all of the occasions, which in their private experience might appear individual, actually contribute to this larger cosmic memory that is objectively immortal and that then becomes part of the data that the next concrescence inherits. And so, yeah, at whatever scale a decision is made, it can become relevant to an occasion at a totally different scale. as a result of this divine milieu, we could borrow one of Teilhard de Chardin's terms to describe the way that Whitehead imagines these interconnections.
Yeah.
So yeah, we can very quickly go from hard science to process theology in Whitehead's universe. Um, yeah, interesting insight. Okay, so for part two, I will shut up and ask and answer your questions, um, and we can get
I'm
more into
happy
the
to have it
philosophy.
as a real dialogue. I think this is really interesting. It really, because my main goal, right, is to build up this understanding of like a coherent worldview where everything that I know somehow fits in, and this is really helping. I think this actual discussions back and forth. So yeah, but
Yeah.
yeah, I'll have some questions definitely as well. But keep
Maybe
on asking
next
as well.
week.
Yeah. Um,
I'll email you. We'll pick a
I'll
day.
email you. I'll have to email you because I'll have to organize with my family.
Sounds
But
good.
that would be great. I'd love it.
All right, Flavio. Thanks very much for answering my questions, and yeah, look forward to next time.
Thank you for your time. It's an
All right.
honor and a privilege. All
Take
right.
care.
You
Bye.
too. Bye.